All right, we're going to continue on with some experiments right here, trying to find different ways to prove triangles are congruent. Okay. One of the ones we had on a quiz the other day and we were looking at was a one where a lot of people thought it was side angle side, but actually it was side side angle. And it did not guarantee congruence. And even some of you were really, perplexed as to why we couldn't say that they were congruent. They looked congruent. But the question right here is, the side angle guarantee congruence? Like, is it always going to happen that way? And the answer we had on the problem we were talking about was no, it does not. And I said I would elaborate on this later and show you. And so I'm going to show you what happens. And this one in the experiment, it says draw a 3-inch side and a 6-inch side and a 25-degree angle that is not included between them. So the angle, because if it's in between them, it is going to work. It would be side angle side. So what I did was I drew these two right here. And what I found out is when I put this 25-degree angle down here and I measured out there 6 inches, and I did the same thing on this one. The first two steps look like they're going to be the same triangle. But what I found out is there were 2 places I could place the 3-inch. I could hit this other line down here because I can hit this other line anywhere because it's not one that's locked in, because this is my angle side that are we know for sure are locked in. So I still have it angle side, but there were 2 places I could put the 3 inches. And just to make you see it like this, maybe, what happens here is this, like I said, this 3 fits out here. And if you kind of swing that like a pendulum, it also fits back here. And so those are the 2 spots that the 3 could be. And so if that's the case, then we know that side angle is not going to guarantee congruence. Like it just will not work because there's 2 ways to do that. So for the problems that even look like they're congruent, we can't say they are congruent because of side angle. So for us to answer this, all right, let's write a little bit right here. How are we going to answer these questions? This demonstrates, okay. So we're just going to say, let's just write a sentence here. There are 2 possible outcomes. Therefore, we cannot use side angle to prove congruence. Okay. And something else you'll find help you remember this. This is kind of silly, but to reverse these letters, you can do that, and it's angle side, which is what a lot of people see at first. Some of you even write that down on your paper, and you don't even realize you're writing ASS on your paper. Okay, so sometimes we jokingly refer to this as the bad word postulate. If we reverse this, it's ASS. And so if you see yourself saying, yes, they're congruent by ASS, then no, that does not work. All right, so maybe you'll see that and be reminded. Okay, one last experiment right here. What if, let's talk about a special case of this one. So if we did side angle, what if we did a special case of side angle and we made the angle a right triangle? So this is a game changer to make it a right triangle. All right, so let me show you some of the experiments I did right here. So what happened is on this one, I did side right angle. Actually, let me show you what I did right there. Side right angle. And so I guaranteed those 2 were congruent. And this was the angle. So that's side angle or angle side. And what I found out is if I have the 3, and I think that's what the experiment said, it said a 4-inch side, a 5-inch side, and a right angle. All right. So those were what I had locked in. So when I did the 4 and a 5 and a right angle, I started realizing, well, according to Pythagorean theorem, which I can use on a right triangle, I can figure this side out. And there's no other way to do this. Even though I did my 4 over here, my 5 over there, my right angle, it turns out that this other side is 3. And it turns out over here that this one's 3. And it also turns out that these angles are identical. And these triangles are actually identical. And it's all due to the fact of Pythagorean theorem. All right. And I did another one over here where I did the 4 and the 5. And this is just where I measured the rest of this. I did my Pythagorean theorem, found out that was 3. Actually, I think I just measured it and found out it was 3. And it was really just because the Pythagorean theorem is working. So this one is kind of a special case of side-side angle. No matter what you do, if you go back and say, we're trying this experiment again, if I lock that thing in at a right angle, or one of these at a right angle, then that distance is going to be the same, and I'm going to have only one way to do this, only one way to create this. So what we need to answer right here, and this is a special case, is are the other 3 parts congruent? Yes. Is it a congruence criteria? Yes, because all of the other parts are congruent. That's kind of repetitive. We do not call this one side-side angle, even though it is SSA. Since it's a right triangle, what we do on this one, and you'll see this marked if I have 2 triangles that are out here, it will always be a right angle because that's a fact, and it'll be one of these legs. Okay, it'll either be that one congruent to that one, and that one congruent to that one. All right, and so if that's the case, then I know you're looking at this and you're saying, hey, but that's the bad word postulate. That's ASS. Well, technically it is, but it's only on a right triangle. So we call this HL, which stands for hypotenuse leg. And when we say hypotenuse, we don't even really have to mention the right angle, because when we say the word hypotenuse, it implies that we are talking about a right angle. So this one's kind of a special case. It's not any A's or S's like the other ones. We refer to this one as HL. And some of you, might be wondering, by the way, when you look at this one, what if it was the other leg marked congruent? Yeah, then it would still be a pair of hypotenuses and a pair of legs and a right angle. But some of you may be wondering on something like this. This is the big common mistake that a lot of people get mixed up. What if we have right triangles and it is marked like this? This one is not HL. All right. Can you answer that before I do? What is it? It is side angle side, because the angle is sandwiched between the 2 sides, and it doesn't matter if it's a right angle or not. But it's definitely not HL because the hypotenuses are not marked congruent. So what we're about to do is we have 5 congruences. All right. Hopefully you can name them. You might pause the video and see if you can go back and look at them. But that's side, 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 angle, side, angle, side, angle, 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 side, and HL. We have these 5 congruences that we're going to use in our homework.